Good morning. We are going to talk. My name is Elisa Mnunuzi. I'm a trainer as well as an inspector. Today, we are going to talk about Banksman stroke slinger course. Just as you see here, training center. Depending on where we are training from, you may find that we'll discuss the alarms, the assembly point, emergency exit, alarms like drills, so like in case of fire, which route can you take? Suppose you're in a building and fire comes, alarms help us to identify the route. Assembly point, in case of an emergency, where are you supposed to gather? Emergency exits, in the case of an emergency, which routes are you supposed to take? Yeah, but for this case, we are not having a specific area where you are training from. We are here online. When in the case you happen to train from one place, you could find gazetted smoking zones. Remember, whenever you go to site or during the training, in the case you happen to go to the site, you will need PPE. Right now, you may not know what PPE means, but you are going to know it with time. Aims of the course. The aim of the course to familiarize delegates with relevant lifting operations, legislation, and regulations. Provide the delegate with knowledge to be able to plan and risk assess lifting operation. Provide basic knowledge for correct selection and safe use of lifting equipment. To raise awareness of common faults, stroke oversights in the lifting operations. Then assess and grade delegates. Now, this course would help you to familiarize yourself with the relevant lifting operations, legislation, and regulations. These are like rules put into place to govern all the lifting operation. Lifting operation is an operation involving lifting and lowering of the load. For example, I'm lifting this, lifting and lowering of the load, or lifting and suspending of the load. Knowledge. This course equips you with sufficient knowledge to be able to plan and risk assess lifting operations. It adds you extra knowledge to understand beyond, especially by you getting this knowledge. It helps you to always plan for any work you are going to do. And risk assessment. Risk assessment is all about identifying those things that have the potential to cause harm to us. To provide you with the basic knowledge for correct selection and safe use, because there is no a lifting equipment, but you fail to select the right equipment for the job. So this course equips you with knowledge to help you out in the selection and safe use of this lifting equipment. It equips you with knowledge. It makes you, it raises your awareness of common faults, such that in case you note something not fine or something faulty, you can easily carry out a risk assessment and plan your job very well. The last thing will be I will have to assess you and see how you understood the work. We go. Now, course content. In our course, we are going to look at Lola. Lola in full is lifting operations and lifting equipment regulations. That will be our first thing. The second thing will be lifting categorization. And here we'll categorize the lift into 4. Then we'll look at lifting planning. What are you supposed to do before engaging in a lifting operation? The next thing there will be risk assessment. Risk assessment. How do you carry out a risk assessment? The next thing will be types of crane and their motions, load indicators and alarms, ground conditions and environment, tandem lift and safe positioning, communication, which types of communication are you supposed to use on phone. Under here, we'll see whether you need to use signals or verbal or radio calls. Another thing will be hands-free lifting and safe positioning. Taglines, then notes, lifting appliances. No, lifting accessories will be next. The mode factors, angles and tensions, containers, cargo handling, personnel transfer. That's our course content. So we'll begin with Lola. Lola will be our first thing. Lola. Lola in full, I told you, it is lifting operations and lifting equipment regulations. It came into force on 5th December 1998. It is commonly known as Lola. Previous regulations were specific and prescriptive, only dealt with existing equipment and practices. Yeah. Lola is goal setting. It lays out objectives. In addition, Lola deals with lifting operations as a whole. Yeah, reference should be made to the approved code of practice. We don't have so much information to get from there. Now, these are Lola regulations, but our major focus will be on regulation 1 up to regulation 11. Once we finish these things, everything will be okay on our side. Regulation 1, it talks about citation and commencement. Roller came into force for all lifting equipment on 5th December 1998. Roller regulates existing equipment, second-hand equipment, leased equipment, and then new equipment. So, mean that even if you have found an equipment on site already working, that equipment should conform or should meet the requirements of roller regulations. Even if you are purchasing a second-hand equipment or you are going to use a second-hand equipment, that equipment should conform to roller regulation. Leased equipment, you are hiring or leasing out an equipment. What you need to ensure that that equipment you are leasing or hiring conforms to roller regulations. It meets the requirements of roller, and we are going to see those requirements below. New equipment, you are purchasing a new equipment. Even if you are purchasing any tool used in carrying out lifting operation, that new equipment should meet the requirements of roller regulations. Roller regulations, L-O-L-E-R, roller regulations. All right, we go. Regulation 2 talks about interpretation. Lifting equipment comprises of lifting appliances and then lifting accessories. In some cases, you'll find that these lifting equipments sometimes you'll find like cargo carrying units, of which I'm going to explain for the cargo carrying units as we go on. I'm back. Lifting appliances. These are work equipment for lifting or lowering of loads. And it includes its attachments used for anchoring, fixing, or supporting it. Lifting accessories. These are work equipment for attaching loads to machinery for lifting. Now, a lifting appliance is like an equipment used for lifting and lowering of loads. I guess each one of you has ever seen a lifting equipment. Maybe that day you were green about anything regarding lifting. You are just seeing something like a vehicle. But by the end of this course, you'll be able to differentiate between lifting and non-lifting equipments. Lifting accessories. These are working equipment for attaching loads onto the machinery. When you try to look at our picture here, I guess you are seeing from the hook to the load is a lifting, anything in between here is a lifting accessory. From the hook upwards plus the crane boom is a lifting appliance. Interpretation. A lifting operation. This is an operation concerned with the lifting or lowering of a load. A load can be An offshore container, like those containers you usually see being transported on big trucks. Even if you are lifting something using your hands, or you are lifting a jerrycan from one place to another, that is also called a lifting operation, because it involves lifting and lowering of the load. Thorough examination by a competent person. This is always about an inspection. Thorough examination is a detailed inspection of an equipment to find out whether it is fit for use, or whether it conforms with the rules, with the regulations put into place. And some of them are LOLA and pure regulations. An examination scheme. This is a suitable scheme drawn up by a competent person for such thorough examination of lifting equipment at such interval as may be appropriate to ensure that it remains in a safe condition. This is like a time frame drawn up by a competent person. Competent person is that person who has sufficient knowledge, skills, experience, trained and certified in a certain expertise, or in a certain, I would use in a certain kind of job. So a suitable scheme drawn up by a competent person for such thorough examination of lifting equipment at such interval as may be appropriate to ensure that it remains in a safe condition. Time frame a competent person draws down to ensure that he carries out a thorough examination. Let me say I can decide to always carry out a thorough examination on my phone after every 3 months, after every 4 months, after 1 week, after 2 days, to ensure that it remains in a safe working condition. What do I do during a thorough examination? Like for the phone here, an example, I will check whether it has some damages. I'll check whether its cover is still in a good condition. I check whether its screen is okay, whether its battery is still strong. So the same thing happens when dealing with lifting equipment. A competent person uses that scheme to ensure that all equipment are being inspected in time to ensure that they remain safe in the workplace. Application. Local regulations apply in Great Britain and outside Great Britain as defined by the Health and Safety at Work Act. I will not go into this regulation. Let us continue to regulation number 4. Talks about strength and stability. Strength and stability. In engineering, health and safety, like the way you see in schools, in primary schools, secondary schools, they used to make English as the leader. English was like the leading subject in a way that when you fail English, you don't get the desired grade. Let me say, for example, Division 1, you get a 9 in English and you get D1, D1, D1 the other side, of which that adds up 12, you are being pushed to the second grade. So instead of having English, in engineering we have health and safety. Health and safety is the driver, is the main point. It is the focal point. Everything done in the oil and gas, every regulation put into place, every procedure put into place, is all about achieving a common goal, which is safety. To ensure that when you're on site, you come on site, you work safely, and you go away safely without getting any injury or getting any kind of sickness. So that's why these regulations were put into place to regulate the activities done when carrying out a lifting operation. A regulation 4 talks about strength and stability. Before beginning any lifting operation, you need to check and confirm that the ground is strong enough to withstand the weight of the crane, whether it is lifting a load or it is not lifting. You have to ensure that the surface is stable. You need to look at the slope. What's the slope of the surface? In the case you find that the surface is sloping, then the crane should be set up in a way that it gains or it gets sufficient level to enable it to work safely without toppling or without failing. Another thing you need to know, whenever you reach on site, you need to try to consult the people around to tell you about the history of that area. You may begin lifting your load when previously, like in 2 days to 3 days back, an excavation was done whereby soil wasn't compacted back, and the process of lifting, one of the outriggers begins to sink the ground, which can make the crane to lose stability, hence failing. And once it fails, you may find that the load may swing, it hits one of you, the crane may break, or the environment may be contaminated depending on the kind of load you are lifting, or even the crane itself. Remember, the crane, when you check, the crane uses hydraulic oil and it has engine oil. So when those chemicals are disposed of or enter the ground, they will bring about what we call contamination. So before beginning any lifting operation, ensure that the crane is on a level, it has attained a level. That is our regulation 4. Regulation 4 still tells us, before beginning any lifting operation, you need to know the size and nature of the load you are lifting. The load may have a big surface area, just like the way you see here in our picture. Because of this surface area, the load can be blown away by the wind. In that process, you find the crane failing or toppling. You need to know, how will the load be lifted? How are you intending to lift the load? You may find the load is too heavy to an extent that you will need an extra crane to come and support the maximum wind loading that may occur. you as a banksman stroke rigger, you have to ensure that the crane operator you are working with does not do any override at any given time. At any given time. It should not do the maximum wind load. I talked about it. Yeah, we continue. Um, Regulation 5 is all about lifting equipment for lifting persons. Criteria for machinery and accessories. Lifting equipment for lifting. Criteria for machinery and accessories which are specifically designed for lifting, lowering, or suspending persons. Standard lifting equipment being used for this same purpose should only happen in exceptional circumstances. Which are for lifting should only happen in exceptional circumstances. I'm sorry. Yeah, lifting equipment for lifting persons. Okay, regulation 5 is lifting equipment for lifting persons. Criteria for machinery and accessories which are specifically designed for lifting, lowering, or suspending persons. Standard lifting equipment being used for this same purpose should only happen in exceptional circumstances. All lifting equipment for lifting persons shall prevent a person being crushed, trapped, struck, or falling from a carrier. Shall prevent a person being crushed, trapped, struck, or falling from a carrier. Every equipment supposed to lift personnel should meet some certain criteria. Just as we have seen, it should prevent a person being crushed, being trapped, struck, or falling from a carrier. Lifting equipment for lifting persons should be made in a way that it will be very hard for the person to fall off the carrier when being lifted. Should have a suitable device to prevent the risk of carrier falling. If trapped in any carrier, personnel are not exposed to danger and can be freed. Has an enhanced safety coefficient. Factor of safety should be inspected by competent person every working day. This is a requirement, whether it is a lifting equipment for lifting persons or not. You should always carry out a pre-use examination on any equipment you are going to use to carry out lifting operations. What is pre-use examination? It is like you are going to ride a bicycle, a motorcycle, or you are going to drive a car. Pre-use examination, it is like these are like pre-checks you carry out to confirm that the equipment you are going to operate or the equipment you are going to drive is still in good working conditions and safe to be operated. If you don't carry out a pre-use examination, you may end up operating an equipment which is not in a good condition or which got an issue. Let me say last night, uh, some person tampered with it, and when you just come and begin driving or begin riding, things maybe it can break down to an extent that you can even get an accident. So pre-use examination is a must. Every lifting equipment for lifting a person should be marked that is suitable for man riding, suitable for carrying personnel. Regulation 7. Regulation 6 is about positioning and installation. Here we have hazards. In the beginning, I told you that hazards is anything or a condition that has potential. It has potential to cause harm to you. When you reach in a place and find that there is something, whether an object or a tool or a condition or a situation that has potential to cause harm to you, that is what we call a hazard. So, Regulation 6 is all about positioning and installation. Suppose you are using a mobile crane to install a telecommunication mast. When they have already installed the lower part, you want to add the upper part, and there are some people in between there who are going to connect. Those people are exposed to some of these hazards. The load striking a person, that part of the mast can strike one of those people who are carrying out the installation. The equipment striking a person, in case there is what we call instability or in case the equipment becomes unstable, it can automatically strike someone. The equipment crashing a person as it moves or rotates, especially if someone tries to move around the swing radius of the crane, it can crash that person. Person falling off the equipment, this can come up as a result of shock loading. What is shock loading? What is shock loading? There's possibility of persons falling off the equipment. Regulation 7 is all about marking of lifting equipment. Every lifting equipment you use should be marked with its safe working load, identification number, and then correct color code. We go to Regulation 8. It's all about organization of lifting operation. Now, under Regulation 8, it states that All lifting operations should be properly planned, adequately supervised, and then carried out in a safe manner. When you look at these people, there is no proper planning, as you see, because these people are here reading newspapers as this one is giving signals. The crane operator is lowering load, but there were some people working around here. These people were just passing here. So, meaning that lifting operation you see was not properly planned, was not adequately supervised, and was not carried out in a safe manner. Regulation 9 is all about thorough examination and inspection. Carry out 6-monthly examination on those lifting equipment or accessories, e.g. slings, shackles. Then carry out 12-monthly examinations on all lifting machines and appliances. Any appliances or accessories, Regulation 9 is about thorough examination and inspection. Any appliances or accessories designed to raise, lower, or suspend personnel must be inspected on a 6-monthly basis. The person examining the equipment no longer needs to be from a third party. It is your responsibility to carry out a pre-use examination. Equipment which is used infrequently can have the periodicity of their inspections extended accordingly. Regulation 10. Reports and defects. Inspectors shall notify the employer of any defect in the lifting equipment which in his opinion is or could become a danger to personnel. In case you carry out an inspection, you examine an equipment and find out that it has some defects, you need to report to your employer immediately or your closest supervisor. Let me first show you some of the defected slings. Yeah, not getting the picture. Yeah, these are some of the sling damages we do not need to accept, especially when you are carrying out a thorough examination. 1. Chemical damage. Whenever you find a sling damaged by chemicals, remove it from use. Another thing is heat damage. Any sling damaged by heat, remove it from use. Any sling, in case you find a hole in a webbing sling, don't use it. Just remove it from the work. Broken, worn, or burst stitching, especially around here, just discard that sling, remove it from work. Wear or abrasion, wear on the sling, not eye damage, damaged fittings. We go. As soon as practicable, make a report of the thorough examination in writing. After carrying out an inspection, make a report in writing. Where there is, in his opinion, a defect in the lifting equipment involving an existing, send a copy of the report as soon as practicable. When you are carrying out a previous examination and you find out that one of the accessories or equipment you are using has defects, you need to make a report as fast as possible, or you report to the relevant authority. Every employer who has been notified of defective lifting equipment shall not use the equipment before the defect is rectified. Any employer, an employer should not use that ceiling before that defect has been rectified. An alternative, like a time period, may be set allowing the defective equipment to remain in service. This may only be given to minor defects to accommodate the ordering of spare parts. Indeed, the defect must not affect the safe operation of the equipment. For example, a crane. You may find one of the side mirror is cracked, and you give them a time frame when they need to fix that side mirror. But in the case you find that the LMI is faulty, load monitoring indicator is faulty, then you need to discard that equipment from service, because if the LMI is faulty, the crane operator will not be able to know the weight of the load is lifting, the boom length, and the radius. He may end up lifting where he's not supposed to lift from, hence causing the crane to fall or causing a serious accident. No time period shall be given to defective lifting equipment which poses an imminent risk of serious personal injury or affect the safe operation of the equipment. If no action has been taken during the first time period of rectify the defect, item shall be withdrawn from service. No further time periods may be given. In the case you have given them like a month, 30 days to rectify the side mirrors and what, and then those days elapse without them working on it, then that equipment should be withdrawn from service. Regulation 11 is all about keeping of information. After making your reports, ensure that the information is being kept and that information will be used for future use. Now we are going on the second part, lift categorization, whereby the organization of lifting operation is flow chart. Lifting operations are divided into two, just as you see here. We have routine and non-routine lifts. Routine and non-routine lifts. Under routine, we have still routine lifts. We have then non-routine. We have simple lifts, complicated lifts, and then complex lifts. Are we together? Routine lifts, these are uncomplicated lifts that are performed on a regular basis, which involve basic slinging practices. Basic slinging practices. What are the basic slinging practices? For example, handling of pipe tubulars. Pipe tubulars whereby pipes have a uniform size, uniform thickness, and uniform weight. Containers. The loading or unloading of trucks. when containers have an equal weight distribution. In the case these containers are loaded, they should be having an equal weight distribution in a way that when you are lifting, the container does not tilt to one side. The loading and unloading of trucks, usually performed by the deck crew, warehouse, or yard personnel. Now, under non-routine lifts, we have simple lifts. Lifts that involve the use of basic hoisting equipment. For example, a crane or manual hoist suspended from dedicated lifting structures, such as pad eyes or runway beams, directed above the load. Then another thing is complicated lifts. These are difficult due to the nature of the load. You may find a load with an awkward shape. The load has an awkward shape. It has an offset or high center of gravity. Let me give you an example. This is our example we are using. We are talking about offset or high center of gravity. When you do the bottle like this, the center of gravity is high, meaning that just mere pushing it will fall. Now, for the low center of gravity is like this, mere pushing it will keep on maintaining the stability. So, under complicated lift is when you are lifting a load whereby just something small can make it to tilt or to fall, or can make it to change the direction. So those are the loads with offset center of gravity. Fragile or containing liquids. For example, just as you see this one is containing liquids. What if liquids have one you are lifting? Let me say when you are lifting lifts, like this, it will keep on doing like this, because you'll find that this liquid will tend to do this, meaning that the center of gravity will not be stable. All right. Yeah, organization of lifting operations. Begin. Complex lifts. These lifts could be any of the first three, like either complicated, simple, or routine, but with additional hazards. E.g., extremely heavy loads, confined spaces, restricted headroom when lifting under restricted headroom, lifting of unprotected plant or equipment, or lifting subsea or on the sea. Just begin to look at routine lifts. These are uncomplicated lifts performed regularly, involving basic slinging practices. For example, handling of pipes, tubulars, containers, loading and unloading of trucks. Yeah, just like the way I've explained to you already. Yeah, just like I have explained to you already. Then we have simple lifts. These are lifts involving basic hoisting equipment. For example, a crane, a manual hoist suspended from dedicated lifting structures. Let me show you here what a manual hoist is. This is a chain block, this is a chain block. So this is a chain block suspended from one point. An example can be this one. Sorry, it is not the thing which I want, is failing to come out. Yeah, but this is a chain block being suspended from one hooking point. These are different examples. So when lifting using such, we call it a manual. But let me get for you just one video. Let me show you. Yeah, this is a chain block, an example of a simple lift. An example of a simple lift.
Hi, my name's Rob and welcome to the Ratchet Shop video series. In this video, we'll be looking at the chain block.
The video is not...
Chain blocks can be a great way to lift heavy loads relatively easily. The internal...
So this is what we call a chain block being suspended from one point. This is an example of a simple lift. And now the load is connected onto this downer hook. Yeah, as he's pulling this, the load will be going up. A chain block or a manual hoist has two hooks. It has the main hook on top where you are going to hook from, and then it has this hook where you are going to connect your load from. So this is an example of a simple lift. It involves basic hoisting equipment. All right, simple lifts, those are simple lifts. Complicated lifts, these are difficult lifts due to the nature of the load, e.g. awkward shape, offset, or high center of gravity, high COG containing liquids, no lifting attachments, difficult to sling. Load may also require to be rotated or crossroad, involving two sets of rigging or tandem lifting. Let us see an example of a complicated lift. What you see here is an example of a complicated lift. It involves this is an example of a complicated lift. It is involving use of two cranes lifting one load. when you focus on our load here, you may find that the load is not balanced, whereby one side may be more heavier than the other. But here, what we are only focusing on, like tandem lift, using two cranes to lift one load. One crane, crane A, and then crane B. Now, when scenarios come that you are going to use two cranes to lift one load, you have to ensure that each crane can lift at least smallest 70% of the total weight of the load. What 75%? What do I mean by saying that it can lift 75% of the total load, weight of the load? Now, if the weight of the load is 100 tons, it means that this crane should be capable of lifting 75 tons. And even this one should be capable of lifting at least smallest 75 tons and above, meaning that it can lift 80 tons, 100 tons, like that. It is able to lift the smallest 75 tons. All right. Yeah. So that's complicated lift. Let me complicated lift. It involves lifting using more than one crane. I guess you have understood, you have picked something out of this. Are we together? Yeah. Let us go to complex lifts. This will be any of the first three categories, but with additional hazards. For example, lifting extremely heavy loads. When the load you are lifting is extremely heavy, when you are lifting in a confined space, just like the way you see here, our brothers are here struggling with the load. Restricted headroom, lifting over unprotected plant or equipment, lifting on the sea. Let me show you when someone is lifting on the sea. Lifting how is lifting on the sea grouped under complex lift? You see, when you are lifting on the sea, there are so many waves moving. So as those waves are moving, they can try to bring about some sort of instability, or the load may keep on swinging. So remember, when you are lifting on the sea, you consider so many things. There are so many things you need to consider. The waves, but this kind of lifts are usually carried out by subsea lifting personnel or subsea lifting specialists. And since most of our work will be on the land, I will not go deep into the subsea lifting, because subsea lifting considers so many factors and so many calculations will come in. Let us continue. Complex lifts. Now lifting in confined space. Let me see whether I can get you one example. Lifting load in a confined space. Confined space. Not got a clear. I fail to get a clear example I could give you, but this can be an example of lifting under limited headroom. Now we are going on another part, which is called lifting planning. Now, every lifting plan begins with a brief description of the lifting operation. What we are going to lift. You have reached on site, you want to start your lifting operation. You need to begin with a brief description of that lifting operation. The lifting plan should start with a brief description of the lifting operation, detailing what you are lifting, from where you are picking it from where or to where you are taking it, which method of lifting are you going to use, and what you describe the weight of the load. That's what lifting plan should always start with. Now, when planning your lifting operation, the most important thing you need to consider, the thing you need to consider first, is the weight of the load you are lifting. You knowing the weight of the load you are lifting, you can easily choose the suitable equipment to lift that load safely. The most important thing to know before is the weight of the load. There are numerous other considerations, so the lifting plan is designed to prove to you accordingly. The weight of the load is the one that helps you to select the right accessory to use. Possible considerations: task categorization. We have talked about lift categorization. The lift categorization, we discuss routine lifts, simple lifts, complicated lifts, and then complex lifts. Lifting plan considerations, weight of load unknown considerations. You need to know whether, and these considerations are the ones that helps you to know whether what you are lifting is routine, simple, complicated, or complex. How do you come up with this consideration? You can go under routine. You put all the factors that makes a lifting operation to be called routine. You put all of them here. You choose for the simple ones. You put all of them here. For complicated, you list them here in your lifting plan, such that when you go, you can just stick out those ones. And when you try to select like this one, these ones, this one, and find out that all the observed factors, then by you looking at what is present, you can easily determine whether the lifting operation you are going to carry out is routine, simple, complicated, or complex. Another thing in a lifting plan is, hello? Yeah. Planning a lift. When planning a lifting operation, you need to follow a step-by-step procedure. The best way to record your plan is step by step, which will help highlight any problems and allow you to rearrange the order of events accordingly. Planning a lift, we have a sketch of a lifting operation. Sketch of every lifting plan should have a clear sketch, and this sketch should easily be understood by you, the rigger or slinger. It should be understood by crane operator. You need to discuss the lifting. You need to look at the lifting plan before beginning any lifting operation. The importance of a lifting plan is to give you to make you to be aware of what you are going to do, where you are going to pick the load, and where you are going to land the load. If the job has not been done before, make a sketch of the lifting operation, which will greatly assist the lifting team to understand the particular task. If the job has been done before and drawing sketches exist, they should be checked for accuracy. This is a must before beginning any lifting operation. If you don't check them, you may end up making an error at a certain point that may result into an accident. Route to be traveled. The route to be traveled is often overlooked, and this can have hazardous consequences. Once again, you have violated what should be considered. Always check out for the route to be traveled, where you are going to pass your boom. The route to be traveled should be free from any obstacles. Rigging stroke materials list. Friend, there is the rigging materials list. This should identify the capacity of the hoisting equipment and fully describe all the associated rigging required. This list should even include access equipment, safety barriers, safety equipment, parking, and rigging protection. 6 easy steps to safe lifting. These are the 6 easy steps to safe lifting. Just as I told you, in your lifting planning, always the first consideration is the load. The load. Establish weight and how it will be slung. The task, where the load is being moved from and to. The rigging diagram, a sketch of how you propose to do the lift, just like the other diagram you saw. Just that the other diagram was a bit congested. The rigging, a detailed list of the rigging equipment required to do the job safely. The procedure, a detailed step-by-step procedure of how the lift will be achieved. The risk assessment, a detailed risk assessment identifying and eliminating stroke mitigating the hazards. A risk assessment is a must. Because the risk assessment will identify those things with potential to cause harm to you, the person who might be harmed, the risks that may come up as a result of the hazard, the mitigation measures to mitigate those hazards and risks. Yeah, that's the risk assessment. So let us look at one by one. Step 1 was the load. Establish weight and how it will be slung. Now, this is an example of the load. You need to know its weight and come up with a proper method of slinging it. 2, the task, where the load is being moved from and to. You need to know where you are picking the load from and where you are landing it. Like in our picture here, they show you that the load will be picked from point A, it will be moved over an obstacle, and then the load will be landed to point B. The rigging diagram. The rigging diagram should be simple and the rigging diagram should be easily understood. For example, here they have showed us that in this, like the load will be picked from point A using LP1, LP2, and then LP3, depending. Our equipment we are using will be a chain block. A chain block, like at this point, this chain block is connected onto the load, and then the load will be lifted from this point to this point, then from this point to this point. The rigging, a detailed list of the lifting equipment required to do the job. For example, the rigging, we are going to see the rigging accessories as we go on, but here you need to describe the identification numbers of those rigging accessories, the length, the capacities of those rigging accessories. The procedure, a detailed step-by-step procedure of how the lift will be achieved. To make the lifting plan easier to understand and reduce the depth of this, allocate the rigging positions, lifting points and load number, a letter, for example. For example, at this point, don't make something to look over congested by writing that lifting point 1. You can just summarize it to be LP1, LP2, and LP3. Now, when you look at our picture here, let me just give you a simple description of the procedure. The load is at LP1. You connect the leg of one chain block to the load at LP1. You suspend it. You move. You pull the chain block to lift the load, like about, let me say, about 2 meters. If the obstacle is around the half meter, like 2 meters to this point. Then you connect LP to a chain block leg, LP2 onto the load. Now when you connect into the load, you also pull shorten the LP2 to ensure that the leg for LP2 is equal to the leg of LP1. And at that point, the load will be pushed into the middle. Then at this point, you lower using the chain block at LP1. You lower like this to increase the length of the chain block at LP1 to push the load into position 2, just as you see. Then from position 2, you can shift this chain block at LP1 at position 2. Let me see. Now it is at position 2. You connect one leg at LP3 onto the load and then disconnect the chain block at LP1. After disconnecting this chain block, or if not, at this point, if you want to use only the chain block at LP1, once you see the load is suspended here, you disconnect it. You shift the chain block at LP1 to LP3. You connect the leg onto the load. You do the same thing. You pull, you shorten. The same thing, since this one is down, you have to first, you shorten the leg of chain block LP1 to enable the load to raise up, and then you lower the leg at LP2 until it reaches the landing area. So that can be the procedure. Now the risk assessment. Risk assessment is essential for reducing the likelihood of having an accident and the severity of that accident should it occur. Following the initial assessment, the next step is identify all the hazards. Identify all the hazards. Determine who or what might be harmed. Under risk assessment, identify all the hazards. Determine who or what might be harmed or damaged and any impact to the environment. Evaluate the risks and decide on precautions to control. Record and implement the assessment findings. Review the residual risk and review and update when necessary. Review and then implement when necessary. We are going to see these ones in 2 details. Identify the hazard, those things with potential to cause harm. Determine who might be harmed. Is it the rigger? Is it the slinger? Is it the crane operator or other people in the community? Evaluate the risks and decide on precautions, or you may find that the person or equipment may be harmed. Now, here let us focus on the hazards. To simplify the process of a risk assessment, the lifting operation can be divided into elements. For example, the load, you focus on the load only, the environment, the lifting equipment, structure, stroke, anchor points, lift area, route to be traveled, and then the landing area. Each element can then be assessed individually. Let us look at the hazards that may come as a result of the load. Attachment point failure. When the attachment point fails, it becomes a hazard. Incorrect slinging method. You are using an incorrect slinging method can be a hazard. Unexpected movement at initial lift may be due to officer center of gravity. The other time I showed you a bottle like this. Supposing this is the bottle, you thought, let me say it has, the bottle is like this. Maybe this is the load, whereby one side of the load is bigger and heavier and one side is not heavy. Now you have connected your cylinders, you are lifting, and then unexpected movement of the load, moving like this, maybe tilting like this to the heaviest side, whereby it can even move and hit someone nearby. So that one becomes a hazard. Excessive load movement during travel and landing. The load keeps on swinging or rotating, can become a big hazard. Sharp edges. Lifting the load with sharp edges. Loads with sharp edges can cut the sling or the sling can cut the load. Snagging. You are lifting and then the accessories you are using, let me say wire ropes or webbing slings, snag on other objects or nearby objects. Temperature of the load. If you are lifting a load at a high temperature, a load or containing liquids at high temperatures can also become a big hazard. Dropped objects. Lifting a load whereby some of the load or load containing elements are keeping on dropping, or part of the load keeps on dropping. Falling from height is also another hazard. Also, the type of cargo, if the cargo has potential to cause harm to you, then it will become a hazard. Which controls can we apply, like in this situation, to mitigate those hazards? Use competent personnel. A person who has the experience, skilled, trained, and certified to do that job. Now, in lifting operation, always ensure that every person is restricted to his or her own responsibility. If you have been given a responsibility to work as a rigger on site, restrict yourself to only that job. If you have been given responsibility to be a banksman, stroke signaler, restrict yourself onto that job. If you have been given the responsibility to supervise the lifting operation, restrict yourself to that job. Even though you have experience in crane operation, even though you know how to operate a crane, you are not permitted to enter the crane unless you have been authorized to do so. Pre-use, lifting, landing, route to be traveled should be verified and to be free from any obstacle. Pre-use examination. Before using any equipment or any accessory, always ensure that that accessory has been inspected and in a good working condition. Now, for load indicators, always ensure that the LMIs have been calibrated and in a good working condition. Hands-free lifting procedures. You are not allowed to touch the load during lifting operations. Always use tag lines when handling such loads. Trial lift. Before lifting any load, you need to always carry out a trial lift to study the behavior of the load. Boom deflection should always be accounted for. Correct use of tag lines, I've talked about them. Protection of the load and the rigging. Safe access and egress. When you are working, always ensure that there is a safe escape route. Don't work in an area whereby in case something goes wrong, there is no way you can escape. Safe cargo handling procedures. You need to follow the health and safety procedure put on site. Environmental hazards. Environmental hazards can be poor visibility, high wind speed, high sea state, vessel movement, extreme heat or cold, slip, trips and falls, fall from height. Harm mitigation measures like lifts should always be carried out in adequate light. Maximum wind speed limits should never be exceeded. Maximum sea state should always be stated. Maximum working and resting period should be clearly defined. Still safe access and egress. Now, hazards associated with the lifting equipment. Equipment failure, just like the way you see in our picture. After connecting the load onto the crane hook, the accessory breaks. So equipment failure becomes a big hazard. Equipment overload. Never exceed the rated capacity of lifting equipment or lifting accessory. Always ensure that the load has been secured properly before beginning to lift. In the case you find out that the equipment you are using has some damages, don't go ahead with the lifting operation, or don't start any lifting operation without ensuring that the equipment you are using is in a good working condition. Equipment suitability, I talked about it under LORA regulations. Our controls, always ensure that the people involved are competent. Pre-user inspection is a must. Verifying load weight is a must. Trial lift before beginning any lifting operation. After connecting your accessories onto the load, first carry out a trial lift such that you can study the behavior of the load. Verify security of attachments. Ensure adequate rigging, loft control and equipment storage. Always ensure that every equipment or accessory you use has been color coded and declared safe for use. Structural ground conditions, anchor points, hazards. Now, when we focus on the environment, like the ground or anchor points, we will expect like structural collapse, ground collapse, anchor point failure, overload, dropped load or lifting equipment, slips, trips and falls equipment stability. Some of the controls, you have to ensure that you are competent to do that job. Always ensure that you know the weight of the load. Pre-user inspection also comes in here. You need to always first assess the ground before beginning any lifting operation. Stability of uncertified steelwork assessed and approved for use. Site surveyed for underground services. If possible, you need to consult the people around about the history of that area. Safe positioning. I talked about that when you are working, the first thing you need to do is to know the emergency exit in case things go wrong. Lift area, the lift area or route to be traveled. These are some of the hazards. The load may drop, crash potential. As you are working, the load can crash you. Landing area collapse, conflicting activities or simultaneous operation. As you are working, there are some other activities taking place. Tag line snagging or personnel entanglement. Load unsettled by the appliance operator. Yeah, those are some of the hazards. The controls, same thing, competent personnel. You need to barricade the area of operation, and you need to add a signage unauthorizing people from entering the working area. Communicate controls to all the people involved. You need to agree on the communication methods. You need to ensure that there is a clear access and egress routes. Emphasize hands-free lifting procedure. You need to ensure that you use tag lines at all times. Never touch the load. Never stand under the load when they are carrying out lifting operations. You need to verify the size and capacity of the landing area of the load. Ensure that the lifting and landing area is sufficient. Define the safe area. Ensure that where you are working from is 100% safe. The success of the risk assessment will depend largely upon how effective it is communicated to everyone. The risk assessment should be communicated to everyone before beginning any lifting operation. Every person involved in the lifting operation should know the hazards and the risks, like those hazards you have seen above, and then the mitigation measures. Wow. Wow, wow, wow. We are going to types of cranes. We have mobile cranes, we have crawler cranes, we have track mounted cranes, we have tower cranes, so many. So let me show you some of the different types of cranes. These are the different types of cranes. We have static cranes like these ones. These ones are usually found in urban centers or urban areas. We have mobile cranes like this one. Mobile cranes like these ones. These ones are almost everywhere. In short, this one is called a mobile all-terrain crane. This one can move from one area to another at normal highway gazetted speeds. We have crawler cranes. Now this is a crawler crane with a telescopic boom, but sometimes you'll find crawler cranes with a lattice boom. We have tracker mounted cranes. Wherever you see a crane of this nature, just know it is a tracker mounted crane. We have rough terrain cranes. These ones operate the same way like the way you see these other cranes, just that for them they are made in a way that they cannot move at normal highway speeds. All terrain crane is the same as this one. Floating cranes. floating cranes, these are usually found on water bodies. Rail-mounted cranes, these are usually found in industries. Then aerial cranes or man lifts, these ones usually manufactured specifically for lifting personnel working at height. A crane works in form of a pulley, like the way you say pulley system. The boom works like a giant seesaw. Its pivot points helps lift heavy loads with less effort. Pulleys increase lifting power. More rope between blocks means more force with less effort. On the crane, you will find, like we call it, force of the rope. You find a crane hook block having like 12 ropes. Let me show you an example. They work in the form of a pulley system, just like the way you see here. Hook block, now this one, it is having like a 4 ropes. These 4 ropes may increase up to like 12, up to 12 depending on the capacity of the crane. Just like the way you see here, like this 1 2 3 4 5 6 7 8. So meaning that this crane, the moment you find a crane with this kind of, it has like folds 1 2 3 4 5 6 7 8. It has 8 folds. You find others with 12 folds, 6 this side, 6 the other side. Others 2 this side, 2 the other side, 3 this side, 3 the other side, depending on the capacity of that crane. We go back to what we are talking about, the types of cranes. Hydraulics, heavy blocks of steel. Now a crane will have counterweights, it will have a boom, it will have pulley system moving over here like this. And then hydraulics, like hydraulics in the cylinders, lift boom extension. You'll find hydraulic cylinders here like this that enables the crane to lift this boom like this and down, as you are going to see some of the examples of cranes. We have with tower cranes. Crane leverage. Someone may ask you that what is crane leverage? Leverage is all about the crane working as a giant lever, whereby a seesaw, giant seesaw, whereby we have effort on one side, fulcrum in the middle, and then load on one side. Mechanical advantage is all about using of pulleys, pulley system like what I've just described as folds of the rope. Counterweights, massive chunks of concrete to keep the crane balanced. Yeah, this one is a track mounted crane, but this one specifically for carrying personnel. This one is a rough terrain crane. Whenever you find a crane of this kind, just know it is a rough terrain. We have all terrain cranes are always in this kind of nature. We have crawler cranes, usually in this form. These cranes are very huge. Some of them are very huge, some of them are not too huge. Carry deck cranes, like this one, usually having a platform whereby some loads can be loaded. Static cranes, we have like tower cranes, like those ones. We have overhead cranes or bridge cranes, usually found in factories. We have gantry cranes. This is a gantry crane. Yes. Then jib cranes usually found in factories. An example of a jib crane is here. Floating cranes usually found on water bodies. Yeah, I think that is all. Types of cranes, we have already seen them. Motions and limits. These are the 6 basic motions of a crane. Jibbing or booming up. Jibbing or booming up to reduce the working radius. Jibbing or booming down, increase the working radius. Using hoist to raise the load and then using the hoist to lower the load. Slew, swing left, swing right. Let us first look at the different parts of a mobile crane. In our picture here, you can see we have outrigger pads, outrigger cylinders, outrigger beams, counterweights. This is the operator's cabin, boom cylinder, boom lift cylinder, access ladders, main hook block. Some cranes will be having auxiliary hook block, which is always a small hook around here. Anti-to block device. It is a limit switch to prevent overhoisting. Overhoisting is when you are lifting the load with the hook block moving up. Main load line. Falls of a rope can be seen here. Main boom head. We have boom tip shapes are always around here. Hook block shapes are always found inside here. Telescopic boom sections. Now for this crane here, it is a telescopic boom crane. This boom can extend by telescoping or by moving out. Main boom length and angle sensor. Angle boom indicator is always found at that point. Telescopic boom section, our number 1. This is the extendable part of the main boom that allows the crane to reach varying heights. It adjusts in length to handle different lifting requirements. So, telescoping is usually described as booming out. Booming out. Then main boom head. This component is located at the top of the main boom and serves as the attachment point for rigging and lifting gear. Main load line. This is the primary cable or rope used for lifting loads. It runs from the winch through the boom and over the sheaves at the boom head. The winch of the crane is usually found at this point. So this wire rope moves like this. It runs over these sheaves. It comes and it moves over sheaves found in this hook block, and the wire rope dead end is secured by an open wedge socket at this point. So by this wire rope moving over here, it makes some kind of a pulley system, whereby the mechanical advantage of the pulley system is achieved from this point, whereby the crane will be able to lift the load at minimum effort, depending on the number of falls found here, just like the way I defined what falls of rope are. And two block device limit switch. This is a safety device that prevents the hook block from colliding with the boom tip. It stops the main load line from being retracted too far. The anti-two block is always found here. It prevents this hook block from hitting the boom tip sheaves. It automatically cuts off the operation of the crane as long as this hook block comes into contact with this overhoist limit anti-two block switch. Hook latch, a safety latch that prevents the load from slipping off the hook unintentionally. The hook latch is always found at this point. It prevents the slings from coming out unless the rigger removes them manually. Access ladder provides safe access for operators to climb up to and from the operator cabin. We saw the ladders here. Boom lift cylinder. This is a hydraulic cylinder used to raise or lower the boom, allowing the crane to adjust the angle of lift. For example, this boom cylinder, it allows the crane, it can extend to lift the boom, or it can lower, it can retract to reduce the angle of the boom to the horizontal. Operator cabin, the control center where the operator manages the crane's movements and lifting operations. Length and angle sensor, sensor that provide real-time data on the boom's extension length and angle. Counterweight, I showed you. Outrigger beam, outrigger cylinder, outrigger pads. Yeah. So the 6 basic motions: booming up, booming down, just as you see. When this boom is going up, it is booming up. When this boom is coming down, it is booming down. Using hoist to raise. This is the main hoist or main hook block. From the other side, I called it a hook block. So main hoist raise, it is when this hook block is going up. Main hoist lower is when this hook block is coming down. Now you will find some of the cranes with auxiliary hooks around here, so there will always be auxiliary hook lower and then auxiliary hook raise. Swinging left. This crane has a slew ring at this point, and like this one has a slew ring at this point that enables it to slew or to rotate from one position to another. Let me show you an example. So when you try to focus on this crane, the crane is rotating. The slew ring is found around here. So it is rotating, lifting the load from this point to the other point. So that's what we call a slew ring. This is called a crawler crane with a lattice boom. This type of boom is called lattice. The other one I showed you was telescopic boom. Safe load indicators. The safe load indicator tells the crane operator the radius of the crane jib tip, the safe working load of the crane at that radius, the actual load on the hook. The load indicator has to be programmed to reflect the current setup of the crane, and the Safe load indicator should always give same values as those ones indicated on the load chart. Alarms. There's normally an alarm system which works in conjunction with the safe load indicator. It works as follows. Not to give you the exact percentage, but I always recommend not to exceed the working capacity of the crane. And in case a crane gives you an alarm, don't go ahead to override. Wire rope terminations. When we are looking at the other crane, I say that the dead end of a crane is always secured by an open wedge socket. So this is what we call an open wedge socket, and the open wedge socket should be connected in this way, whereby the live end of the wire rope is in line with the connecting point of the open wedge socket onto the crane. Ground conditions, we talked about them. When you are working under near an exposed edge, always ensure that the distance you are supposed to put the crane at a distance 2 times the depth of the excavation. Like the distance from here to this edge should always be 2 times the distance of this excavation. Power cables. The jib must not come within 15 meters overhead power cables. When you are working near overhead cables, always ensure that the boom, this is the boom, doesn't come into the distance of 15 meters from the power cables. 9 meters if the electric power lines are supported by wooden poles. Busy worker sites. Onshore, the busier the work site, the more chance of collision. When we are talking about lifting planning, I talked about ensuring that the route to be traveled is clear of any obstacle. I emphasized barricading the area of operation, risk assessment, previous examination. So in case you are working in busy areas, always ensure that the route to be traveled is clear of any obstacle. Tandem lifting. When carrying out tandem lifting, I already explained this. You need to ensure that each crane can at least lift 75% of the total weight of the load. Remember, one crane will end up supporting the full load, and then when you are and when these cranes are lifting, always ensure that they lift the load systematically in a way that one crane doesn't leave the whole weight to one crane. Hand signals. These are hand signals. This is the stop signal. This is the emergency stop. This is the signal for taking the strain. Whether we're taking the strain, this is the stop signal. If you are telling the crane operator to stop in case has been lifting or lowering or slowing the crane, you give him like this to tell him to stop. Emergency, you use 2 hands like this to tell him in case there's an emergency or there is unsafe condition raising, you can give him an emergency stop. We have hoist up. This is the signal for hoisting up. You are telling him to lift the load or lower the load, or to lift up the hoist. I already showed you the hoist. Yeah, lowering. Yeah, lowering. This is the signal you use to tell him to lower. Slewing. This is the signal. You only point in that direction. You point in that direction where you want him to slew. Jibbing up or raising the boom. This is like this. This is raising the boom up. This is the signal. Lowering the boom. This is the signal you give. Extend the boom or retract the boom. Extend the boom. This is the signal you give. Retract the boom. This is the signal you give. Travel to me. This is the signal you give. Travel from me. This is the signal you give. This is operation, just like the way you see here, the image. Radio communication. Always ensure that the transmission button is fully depressed before speaking into the microphone. Identify the station you are calling. For example, West Crane. You may find that when you work in a workplace whereby you are almost doing the same job, the communication needs to be a bit connected. So you need to first, or you may find you are in a workplace whereby you are using one channel. So you need to always first identify the people or the group you want to communicate to. For example, West Crane, you speak slowly and clearly at all times and finish your transmission with the word over. Do not release the button until a few seconds after completing your message. You're talking about radio communication. Please ensure that the transmission button is fully depressed before speaking. Just as I say that you may find you are working or you are using one channel on the whole site, you need to always identify the exact person you are speaking to. Speak slowly and clearly at all times and finish your transmission with the word over. Do not release the button until a few seconds after completing your message. The receiving operator should indicate understanding of the message by saying Roger. If the message is distorted or the instructions are unclear, they must request for it to be repeated. The transmitting operator should never assume that the message has been understood until he hears the word Roger. At the close of communication, the transmitting operator must indicate the end of the transmission by saying out. Hands-free lifting. Previously, I've been talking about hands-free lifting, tag lanes, and what, and yeah. Once connected to a mechanical lifting device, personnel should not touch a load with any part of their body. as the load is being lifted or before the load is properly set down and any potential energy has been released. Most accidents happen when loads are being lifted or being landed on the ground. So because of this, it is not recommended for you to touch the load when being lifted. That's why hands-free lifting procedures were brought into action to ensure that you don't touch the load when being lifted at all times. When lifting the load, always ensure that you use an appropriate either tag line or a pull or push stick. For example, when you look at this image here, this person was trying to lift the load and he was using his own hand maybe to guide it where it is supposed to be, and unfortunately one of the lifting points broke. What happened? The load had to hit him, and this load can lead to serious or can cause very serious, can bring about serious injuries. Lifting off. When the hoist or crane takes the strain, any errors in the system will manifest themselves. Always ensure that you carry out a trial lift. Trial lift helps you to know whether the load is balanced or not. Landing. When landing a load, the hoist usually stops the load before lowering fully. This can result in the load swinging, bouncing, or toppling, the rigging slipping or failing, dislodged items falling from crane or the load. What do we need to be able to achieve hands-free lifting? 1. The correct mindset. 2. Taglines, push or pull sticks, rules of task planning, think planning process, follow the planning, the lifting plan. Safe position during lifting. Work out where any falling, toppling, or swinging load or equipment could end up. Then make sure that neither you nor anyone else is in the straight path should anything fail. Never position yourself between the load and another solid surface. Always have an escape route in the event of a rigging failure. Never travel a load over a person, and never allow a person to ride the load when it is being lifted. Drop cone effect. When you focus on this image here, we have the dropped objects, boom collapse, crane tipping. In case something goes wrong, this is where we expect some of these things to drop or some of these things to happen. So whenever you are carrying out lifting operations, you need to know this, that no one should stand under these zones. Push or pull sticks. These are simply aluminium or fiberglass poles with a bolt hook at one end and a rubber or leather pad at the other end, just like the way you see here. Proper use of tag lines. Achieving hands-free lifting is not difficult, it's proper planning and execution. Tag lines. Tag lines tend to be used in pairs and are soft lines, usually polypropylene. They should be made up from single or continual lengths of rope, no joining ropes. Wherever possible, tagline should be tied to the rod and not the rigging, because when you tie tagline in the rigging, it can tend to increase the tension in one of the legs where you have tied that tagline, because you keep on pulling and pulling and pulling. Wherever possible, tagline should be tied to the rod and not to the rigging. The length of tagline should be such that personnel using them to guide the rod can stand well clear of the rod. Tagline should be long enough to enable you to stand away from the rod. Although their use can introduce additional hazards such as snagging on surrounding structures, their use generally increases the safety of lift. For guidance, taglines are normally used for rods which are being lifted to a height out of normal reach, and if they fall into the following category: especially long rods which may tend to rotate when lifted, light rods which may be blown about, rods with a large surface area which may act as a sail, rods being landed opposition in confined spaces, rods of awkward shape which cannot be safely guided by hand, personnel transfer basket and worker baskets. Safe use of taglines should be used in normal operating conditions and not as a control to enable lifting operations to be carried out in adverse weather conditions. In the case of an adverse weather conditions, you don't need to say that I'm going to use taglines and you continue working in adverse weather conditions. Ideally, should be held at an angle of 45 degrees to prevent personnel getting too close to a suspended load. Should be held in a such manner that they can slip through the hand if required, or in case things go wrong. All sections of the line, including slack, must be kept in front of the body, between the handler and the load. When two or more persons are handling the same line, all must work on the same side of the line. Particular care must be taken when using taglines while wearing gloves to ensure that they do not entangle the glove. I think I will just put a video here after. Notes. We have clove hitch. The clove hitch is a good binding knot. However, as a hitch, it should be used with caution because it can slip or come undone if the object it is tied to rotates or if constant pressure is not maintained on the line. The bow line is most commonly used for forming a fixed loop, large or small, at the end of a line. It is reliable, strong, and stable. Now we are going to begin looking at our rigging accessories, and the first one is a wire rope sling. A wire rope sling has a thimble, a ferrule, a thimble, and a ferrule. A thimble is usually a reinforcement, and then a ferrule is usually a mechanical splice. These are types of the wire ropes. We have a wire rope with thimble on both sides, a wire rope with a thimble on one side, and then another side has a reeving thimble, one side a thimble and another side a soft eye without reinforcement, An endless wire rope sling, soft eye and soft eye. Let me show some examples of wire ropes. These are some of the wire rope slings. Like this one has soft eye and soft eye. It has a soft eye. This is a wire rope sling, soft eye. This is one is a fell, the soft eye. It is a single-legged wire rope sling. Single-legged wire rope sling. We have this one with reinforced eyes with thimbles. These are thimbles, reinforcements in the lifting eyes. CE marking, reinforced eye. We have wire rope sling with legs, four-legged wire rope sling. Like this one has 4 legs. These were single legs that were connected onto one master link, and then hooks were connected at the other end to make it a 4-legged wire rope sling. Now, wire rope sling is constructed in a way that wire rope sling is made up of strands and then a core. Some of the wire rope sling are having an internal fiber core or a metallic core, just like the way you see at this point. Like this one, it has 6 strands in the outer layer and then a middle fiber core. Previous examination of a wire rope sling. Always ensure that the safe working load is adequate. The color code is current and sling has a plant number or identification mark. This is like a manufacturer's identification number. Check for wear, corrosion, abrasion, mechanical damage and broken wires. Ensure the correct size of ferrule has been fitted. Check that the end of the loop does not terminate inside the ferrule. The ferrule should be free from cracks or other deformities. Examine each thimble and check for correct fitting, snagging or elongation. Examine a wire rope around thimbles. Examine master link, quadruple assembly and check for wear, corrosion and cracking, and ensure safety latch functions if it has been fitted with a hook. These are the 3 main configurations or modes. We have a straight pull, we have a basket hitch, and then a choker hitch, whereby a choker hitch you pass one eye into another eye and lift at a given angle. Basket hitch, overhauling the load, just like the way you see. Straight pull, this is what you call straight pull, whereby the crane hook will come and hook from here and you connect the load from the bottom here. Straight pull, using thimble will protect the eye and increase D over D bend ratio. Never attach the eye to a fitting that has a smaller diameter or width than the rope's diameter. Never attach the eye to a fitting with a diameter greater than half the standard eye length. Bending. Bending a wire rope around an object has an effect on the capacity of the rope. The outside wires and strands at the bend have to stretch further and therefore take a greater percentage of the load. Choker hitch. Depending where you are in the world, the choke hitch has a self-working load of between 75% and 80% of the original self-working load based on a 135-degree angle, just like the way you see. Meaning that when you choke the load, it will reduce the capacity by 20% or 25%. If the self-working load of this wire rope is 1 ton, then by you choking it, the self-working load will reduce by 20%, making it 800 kgs or 75%, depending on the angle. Choker hitch. If you are using choker hitch to turn a vessel or have a smaller angle, then the capacity will again decrease as below in addition to the original duration. If the angle is between 0 and 30 degrees, the capacity will reduce up to 48%. Meaning that if you are to lift, you need to consider 48% of the safe working load only. If the angle between 31 and 60, you need to always consider safe working load will reduce to 60% of the original safe working load. If it is between 61 and 90, the safe working load will have reduced to 75% of the original safe working load. Now in our example here, you will see 75, 0.75, and you will ask me where it came from. This 75% helps lifting operations to be kept in the safe window. It is always recommended to use 75% of the capacity of either lifting appliance or a lifting accessory. The 75% helps you to cater for other dynamic factors that may come in case, especially when you are carrying out a lifting operation. For example, maybe lifting a load and stronger wind comes in abruptly, whereby lowering the crane will take some minutes, whereby, and the more minutes it takes, the risk will always be high. The crane can even topple in those few minutes. So when you lift like around considering 75% of the capacity of each, whether an accessory or a crane, the remaining 25% can at least cater for those dynamic factors that come in, whereby when the wind comes in, the crane will tend to become unstable. So when it becomes unstable, when you have been lifting when you have been using its capacity, almost half of its capacity, you'll find that at least the dynamic factors will try to increase the instability to around 80% of its capacity, and you'll be able to lower down the crane safely without getting any accident. Basket hitch. This configuration mode in general purpose offers to reach the capacity, but only if the diameter of the load you are lifting makes a bend ratio greater than 25 to 1, whereby 1 is for the diameter of the wire rope and 25 is the bend ratio for the diameter of the load. Basket hitch. Again, with general purpose rigging, this configuration mode, its length is only increased by 40%. This is because of the angle these slings will be making with the horizontal. Slinging the tubular bundles. When slinging the tubular bundles, ensure that all the tubular bundles are having the same diameter. All these pipes should always be having the same diameter when lifting. And when choking these tubular bundles, never bring a hammer to hit that you are trying to tighten. All the bundles should be having the same diameter and same size. Always ensure that the angle in between here and here does not exceed 90 degrees. 90 degrees, by you considering 90 degrees, you have considered the other 75%, 75% I talked about. So meaning that you will be keeping yourself in the safe window. But the maximum is 120, whereby 120 will be worked like at the maximum capacity. Tubular bundles, here never do this. Like never bring a hammer, just like what I explained before. Multi-leg slings, I already showed you these things to you. The 2-leg slings, the 3-leg, the 4-leg. Now we have shackles, we have the bow shackles, and we have shackles, and then this is like just trying to demonstrate wire rope slings with thimbles, then the wire rope sling without thimble. With thimbles, wire supported; without thimbles, wires will tend to flatten. Angles and the tension. Tension in legs increases as angle between them increases. This is what I was talking about. When the angle, the included angle is 120 degrees, the tension in each leg will be equal to the weight of the load, as long as you are lifting a load with a uniform weight. If the angle is 90 degrees, then the included tension, the tension in each leg will almost be 70% of the weight. The smaller the angle, the less the tension in each leg. Man-made fiber slings. Various types are soft bracketed eyes, endless or flat webbing slings, endless or round slings, then slings with metallic endings. Format with soft bracketed eyes. Soft bracketed eyes like these ones, lifting modes, they are multi-purpose. With D-links, just like this one here, straight or basket lifts. With D-link and removable, straight basket and choke lifts. Endless or flat webbing slings can also be used multi-purpose, meaning that they can be used to lift in all modes. Man-made fiber slings. Pre-use examination. Always check out for cuts, tears, or chafing. Burst stitching, especially around the eyes. Chemical damage, heat damage, ingress of foreign bodies into the fibers, distortion, or wear in the metal eyes. Always ensure that safe working load is adequate. The slings are having the correct color code, are having an identification number. The correct color code usually describes the inspection status of the webbing slings. Just as I told you under risk assessment, always carry out a pre-use examination before you use either an accessory or a lifting equipment. Chain slings. Chain slings also work in the same form like the way you see wire rope slings. You will always find chain slings in different configurations: single leg, endless, double leg, chain sling with clutches, 3-legged, 4-legged with clutches, and then barrel sling, just like the way you see. Prior to using any chain sling, the following checks should be made. The first three things: safe working load, correct color code, and then manufacturer's identification. Lay out the Chinese slings on the floor or suspend from the crane hook. Remove all the twists from the legs. Match up the legs and check for stretch deformation in the individual legs. Visually examine each leg along its entire length and check for distortion of the links, e.g. bends, twist elongation, and nicks. Check for heat damage or chemical damage. Examine end terminations, e.g. hooks and connectors, and check for wear, stretch, and distortion. Ensure safety catches function. Ensure all load pins are secure. These are some of the damages, like worn links. You find a link worn out, a link bent, stretched links, gouged links. Chinese link, correct method of use shortening clutch. Shackles, we have bow shackles and then D shackles. We have bow shackle safety type and then bow shackle screw pin. D shackle safety type, D shackle safety pin. These are bow shackles. Parts of a bow shackle: identification number or owner's identification. It can be a name or a logo or a code. A crown, this is the body, ownership identity, identification number. Check for wear and straightness of this bolt, threaded leg, shackle angles of use. Always lift either at straight in line or at an angle 45. Shackles, good and bad practices. This is a good practice. This is the eye of the sling. This can be a wire rope sling. It can be a chain sling. Never do this to a shackle. The shackle will break. This is incorrect. Wrong shackle pin fitted. You have to always ensure that the shackle has been fitted with a correct pin. Eyebolts types, these are eyebolts, dynamo, collar eyebolt, collar with link. Safe use of eyebolts. The safe working load is adequate for the load. The color coding where applicable is current and the eyebolt has a plant stock ID mark. Examine the threads and check for wear, stretch or impact damage. The threads must be complete. The threads should be concentric and fit neatly in the standard nut. Examine the eye of the bolt and check for wear, stretch, distortion, and look for hairline cracks at the crown of the rings. Check squareness of the shank, like this one, against the shoulder. Examine tapped hole and check thread condition. Safe use of eyebolts. You need to use eyebolts in this form, but not in this form. Hoist rings. You also find hoist rings. The actual bolt part of the hoist ring is made from a very high quality alloy steel and is stronger than the equivalent size of the eye bolt. The two other main advantages are that hoist rings will swivel to the correct orientation, no requirement of packing with trim washers. This is like a hoist ring. This part here can rotate. Correct usage. As with the collar eyebolts, ensure the bushing flange is in for 360 degrees. Never replace the bolt with a standard bolt. We have BK type hooks. The rod closes the hook. Hook locks in a closed position. Does not snag on handrails. Spreader beams. We have spreader beams usually used to lift unbalanced loads, balanced and unbalanced loads. Never return defective gear to the rigging store. Container standards. These are containers, plates, schedule for examination and test, which is always carried out proof load test, then NDT visual at intervals every 6 months. No, proof load test is not carried out, or NDT is usually carried out by description of the inspector. Intervals of 12 months. No, not proof load test. Yeah, it is. The NDT is carried out after 12 months for containers, like those ones usually see on trucks and what. Intervals of 24 months. Yeah, proof load test is usually carried out at the interval 4 months. Also, NDT can be performed. Substantial repair in case it has been repaired, NDT is carried out. Containers. This is a container. Factors which affect inspection. Usually these are the factors that hinder inspection. When the job is needed urgently, you may find that someone tends to violate the standards and does the job without inspecting. The existing workload, when there is too much work or too much worker pressure. Weather conditions, insufficient light, availability of a forklift or crane, or availability of a replacement unit usually tends to cause delay in the inspection. Containers. Always ensure that you carry out an inspection before lifting a container. Don't be like this man. He came, he did maybe just filled in the checklist without checking whether the container is good, and after leaving, this is what happened. Inspection. When loading into a container, always check the capacity of the cargo carrying unit you want to load. Check certification date, check condition of the gear you are going to use when lifting it. Remove all the hazard labels. Place heavier cargo at the bottom, pack between freight items. Lash down or wedge cargo. Check drainage holes. Use door safety nets. Attach new hazard labels. Never overload the cargo carrying unit. Ship a cargo carrying unit with less than 1 month's certification remaining. Ship cargo in a damaged or substandard or with damaged slings. Never ship cargo. Never ship a CCU with less than 1 month certification remaining. Never place heavy cargo on top of fragile cargo. Never ship cargo loose or uninsured in the CCU. Yeah. These are the same things we saw. Door safety nets. A very good safety feature, but unfortunately not always fitted. Be careful when opening containers. You may find the container was fitted with or was overloaded. So in the process of opening the door, the loads will come and fall on you. Parking. Always ensure that in case you observe that the load can tend to cause friction, always ensure that you park at them to prevent friction. Or you are lifting a load. Let me say you are loading a metallic load onto a truck. Remember, a truck bed is metallic and the rod is metallic, so it might end up causing friction, so you need to pack it with wood or rubber. Yeah. When releasing this training device, be aware of any stored energy in the system and that the rod may. This I talked about this. Yeah, that's the end of